Lesson 115 is about polygons, congruence, and transformation. Now, a polygon is just a closed, two-dimensional figure made up of straight lines. Now, go ahead and pick 3 of these to copy into your notes. You don't need to copy them all. These are all examples of polygons because they all have straight lines, they're all two-dimensional, and they're all closed. If we look at another figure, let's say we use our toolbar here and we pick this figure, it's like a sector. This, in red, is not an example of a polygon. It is closed, it is two-dimensional, but it's not made up entirely of straight lines. So this is not a polygon. The rest of the figures are. Let's look at our next slide. So we've got different types of polygons. For this table, please pause the video at some point to make sure that it gets into your notes. We know that polygons are named based on the number of sides. So we have 3 sides, we've got a triangle, 4 sides is a quadrilateral, 5 sides is a pentagon, and 6 sides is a hexagon. 7 sides, that's a heptagon, 8 sides is an octagon, 9 is a nonagon, and 10 is a decagon. 11 is an undecagon, and 12 is a dodecagon. Now below, we say n sides is an n-gon. So after 12 sides, we don't have any specific names anymore. So if we had a 13-sided polygon, we'd call it a 13-gon. If we had a 147-sided polygon, we'd call it a 147-gon. Or we could call it a gon if you wanted to. 147 a gon, that would work as well, or 13 a gon. Let's look at our next example. There's 2 types of polygons that we could have. We can have a regular polygon or an irregular polygon. A regular polygon means all sides and angles are equal length. So if we use our toolbar again, let's look at a square. A square is an example of a regular polygon because all the sides and angles are equal. An irregular polygon, all sides and angles are not equal. Well, an example of that would be a rectangle because all the sides are not the same length, even though the angles are the same length. Since the sides are not, that makes it irregular. Let's look at another. Here we've got a pentagon. If we draw this pentagon, this one looks like it's regular because all the sides are the same length and all the angles are the same measure. If we draw another pentagon, let's draw it like this. You can see clearly that all the side lengths are definitely not the same length. So it's an irregular polygon. Let's look at our next example. Classifying quadrilaterals. Quadrilaterals are one of the most common types of polygons we'll work with. Again, pause the video at some point to make sure you get this into your notes. We've got the shape on the left, the characteristics of that shape in the middle, and the name of the shape on the right. A trapezium means there's no parallel sides. A trapezoid means there's one pair of parallel sides. A parallelogram means 2 pairs of parallel sides. A rhombus is a parallelogram with equal sides. So we can see here that we have a rhombus. A rectangle is a parallelogram with right angles. So we've got a parallelogram, 2 pairs of parallel sides, all with right angles. And a square is just a triangle with equal sides, a rectangle with equal sides. So this is really just a rectangle, but all the sides are equal. And that's known as a square. Pause the video if you need more time for this slide before we move on. Now whenever we talk about polygons, we can move polygons back and forth, up and down, we can flip them, we can rotate them. And here are the types of transformations or movements with figures. We can have a rotation of a figure, which means we're turning the figure around a certain point. We can have a translation, which means sliding a figure in one direction. Or we could have a reflection, which means mirroring or flipping a figure over a line. We do have a bunch of notes today. Make sure you've got these so you can refer back to them when you have questions about polygons. Let's look at an example. We want to rotate this figure 90 degrees clockwise. If we want to rotate this figure, using a tool on the computer can be very handy to visualize that. If we want to go clockwise, of course, we're going to be heading in this direction, like a clock. We can use our rotation tool to move 90 degrees clockwise, and we'd have our answer right here. So we've gone from our original, and we've moved it so that it's 90 degrees clockwise. If we were going to draw that, what we would have to do is we'd have to visualize this piece going 90 degrees. And if we visualize that piece going 90 degrees, we would have to come up with a figure that would look like this. And we'd have our answer. Now I'm going to erase this one and redraw it because our new figure should be the same size as our original figure. And when two figures are exactly the same shape and the same size, then they are considered congruent. Let's look at another example with a transformation. Describe the movement of the shapes below to get from figure 1 to figure 2. Well, these shapes are exactly the same pentagon. They're the same size and the same shape. They're congruent. All we've done is move shape 1 to the right. So this is an example of a slide. Or we could also call it a translation. Let's move on to our next example. Describe the movement of the shapes below to get from figure 1 to figure 2. Well, to get from figure 1 to figure 2, look back to your notes again, and look at where it says a reflection. This must be a reflection because it's being flipped over a line. If we took shape 1, that triangle, and we flip it or mirror or reflect it over this line, we're going to get where we are in figure number 2. So describe the movement. This must be a reflection. You could also call it a flip, or you could also call it a mirror. And all three of those answers are correct, so all three of them would give you full credit. We had a lot of concepts today. Many of them may have been review for you, that's good, but we'll practice some more with our lesson practice on page 360. Make sure you've got your notes complete, and I'll see you during our next class.